Hi everyone and welcome to Sums of Anarchy Let's Solve. This is video 3 of a 4-part series in which we are working our way through the November 2021 Edexcel higher tier non-calculator maths paper. We'll put a link in the description to the paper as well as the previous 2 videos. So in this video we're going to be tackling the next 6 questions. Let's go. Okay, question 11. The diagram shows 2 rectangles, A and B. All measurements are in centimetres. The area of rectangle A is equal to the area of rectangle B. Find an expression for Y in terms of W. So what does that mean, find an expression for Y in terms of W? Well, that means that we need something that sort of looks like Y equals bunch of W's. There might be some numbers in there as well, but it's going to be Y equals and then something to do with W on the right hand side. So that's what we're aiming for. So what do we need to know in order to do this? Well, it's told us that the areas of these rectangles are equal. So how do we work out the area of a rectangle? Well, we do the length times the width. So for the area of rectangle A, we've got this 6 times by 2W plus Y. So let's use some brackets to write that. So the area of this one is 6 times by 2W plus Y. That makes sure that the whole of that expression gets multiplied. And then the same again for rectangle B. The area of this is 3Y plus 6 multiplied by 7W. So again, I'm going to use some brackets here. 7W times by 3Y plus 6. Now these 2 areas are equal, so let's put an equal sign here. Okay, now we've got an equality, and what we're aiming for is to have Y on the left hand side equals bunch of W's on the right hand side. So the first thing we're going to do is expand out these brackets. So we're going to do that by multiplying the term on the outside of the brackets by each of the terms inside the brackets. So to begin with, we've got 6 times 2W, that's going to give us 12W. Then we've got 6 times Y, which is just going to be plus 6Y. Okay, so that's going to equal, on the right hand side, we've got 7W times 3Y. So we multiply the constants together, 7 times 3 is 21, and we just write down the 2 letters WY. Then we've got 7W times a plus 6, that's going to give a plus 42W. Okay, so we want all of our Y terms on the left-hand side. So let's see where they are. So we've got this one here, this 6Y, and then we've got a Y here. It's embroiled up with some other letters, but we'll take everything over to the left-hand side first, and then we'll see if we can deal with the 21W afterwards. So let's start by getting rid of the 12W on the left-hand side. We don't want any W's on the left-hand side. So the opposite of a 12W is subtracting a 12W. So if we minus 12W from both sides, that's going to leave us just with this 6Y on the left. And on the right-hand side, we have to subtract a 12W. Okay, next step was we wanted to bring over this 21YW to the left-hand side, so we need to subtract it from both sides. If we subtract it from the right-hand side, well, it just won't be there anymore. We'll just be left with 42W minus 12W, and then we subtract it from the left-hand side, and it ends up over here. Okie dokie. So now if we look at the left-hand side, we've got 6Y minus 21WY. We can factorise out a Y. That's going to be really helpful because it's going to get that Y on its own, which is what we need. So let's pull out the Y and see what's left. Well, to get the first term, we would have had to multiply by 6. So there's just a 6 left to make 6Y. And to get the second term, we would have had to multiply by a minus 21W. So that's that left-hand side factorised. Let's see what's going on the right-hand side. We've just got 42W minus 12W. That's going to be a 30W. So things are looking better already. But we've got to get rid of this 6 minus 21W because that involves some W terms and we don't want those on the left-hand side. So at the moment, the Y is multiplied by 6 minus 21W. What's the opposite of multiplying it? It's dividing by it. So we need to divide by 6 minus 21W on both sides. What that's going to do is on the left-hand side, it's going to leave us with just a Y. And on the right-hand side, we're going to have that 30W divided by 6 minus 21W. Now, if we want to be especially fancy, we could divide all the terms by 3, and we'd end up with 10w on the top over 2 minus 7w. So now what we can see is we do indeed have an expression for y in terms of w. We've got y equals bunch of w's. Okay, question 12. The cumulative frequency table gives information about the heights in centimetres of 40 plants. Question A, on the grid, draw a cumulative frequency graph for this information. Okay, so cumulative frequency is a bit like a running total. It's like adding everything up as you go along. So if we have a look at this chart here, we'll see that the first section says the height of 0 to 5, and there are 4 plants. So what that means is up to and including the height of 5, we've got 4 plants. But then up to including the height of 10, we've got 11 plants. So we're adding them up as we go along, and that means that our final number, we should have our total number of plants, which is 40. So how do we plot a cumulative frequency graph? Well, we take the highest point in each segment. So in the height, we've got 0 to including 5. We're going to plot at the 5. We're going to plot the 5 at 10, at 15, at 20, at 25, and at 30. Each time we're going to plot the frequencies at the upper bound of the segment. So let's have a look at our graph. Okay, so the plants up to including 5, so that's 5 on our height here, and there are 4 of them. So let's put a little cross at 4. Okay, up to and including 10, there are 11, so we go to 10 here, and we're going to plot 11. And then up to and including 15, so we're going to plot that at 15, that's going to be 24. Up to and including 20, we have got 34 plants, so that's all the way up here. At 25, we're going to be plotting 38, and at 30, we are going to be plotting 40. Okay, so now what we want to do is we want to connect up these dots. You can either do it with a smooth curve, or you can join each dot up with lines using a ruler. So I'm going to go for a smooth curve. You should always do this in pencil just in case you muck up and you need to do it again. So let's give this a go. That's not the end of the world. Okay, so we have drawn our cumulative frequency graph for this. Part B, they want us to use the graph to find an estimate for the median height of the plants. So the median is the middle number. So if we were to put all of our results in a row, it's the middle number. Now let's have a look. How do we find the median? So we've got an even number of plants here. We've got 40 plants in total. Let's just have a look at an example. Suppose that we had 5 plants. It's quite easy to see that the middle number would be the third one. If we have 6 plants though, the middle is going to be somewhere between the third and the fourth. So that's what happens. We have to add 1 to our total number and divide by 2. So if we do 40 plus 1, that's going to be 41, divide by 2. The median is going to be at 20.5. So let's go to 20.5, which is going to be about here. Let's get a slightly thicker pen so we can see it. So it's going to be about here. I'm going to make my way into the graph and meet it here. Okay, and now I'm going to make my way all the way down here. Right, so I need to read this off. So first we need to work out the distance between these squares. So every 2 squares is worth 1. So that's going to be 11. That's going to be 12, that's going to be 13, that's going to be 14, and there's 15. So that looks like it's about 13.6. Now your answer might be slightly different depending on how well you've drawn your curve or whether you've used a straight line, but they'll probably give you a tolerance of somewhere between 13 and 14 for your answer. Okay, question 13. Ted is trying to change 0.43 to a fraction. Here is the start of his method. So he's let x equals 0.43 recurring. I think there should be a recurring there, shouldn't there? He's trying to change 0.43 recurring, so that's 0.434343 to a fraction. So he's let that equal to x, and then he's multiplied by 10, and he's got 4.343434, and now he's trying to do 10x minus x. So the question wants us to evaluate Ted's method so far. Sorry, Ted, it's not going to work. Now, I think this question is for 1 mark, so we need to give a 1 mark explanation as to why how Ted's method is going. Okay, so Ted's method will not work because what he should have done, he's got 2 digits that are recurring, so what he needed to do was work out 100x. So he needed to multiply by 100 and that would have eliminated the recurring decimal. So we can write something like, Ted should have found 100x to eliminate the recurring decimal. Better luck next time, Ted. Okay, question 14. Here is a shape with all its measurements in centimetres. The area of the shape is a centimetre squared, and we need to show that a is equal to 2x squared plus 24x plus 46. Okay, so we're going to have to work out the area of this shape. Now, we're not that familiar with working out the areas of L shapes, but we are familiar with working out the areas of rectangles. So the best thing to do is to cut this up into 2 rectangles. Now, it doesn't really matter. We could cut it this way into 2 rectangles, or we could cut it this way. Now that's the way I'm going to go for because I think we'll have a little bit less algebra to do. So what we need to do is we need to fill in the length of this missing side in order to be able to work out the area of this bottom rectangle. So if we know that the length from top to bottom is x plus 11, and we know that this part is 4, that means that this missing part has to be x plus 11 minus 4. So that's just going to be x plus 7. Because if you add together x plus 7 and that 4, you're going to get x plus 11. So now we've got that missing side. We can set about working out the areas of the rectangles. Okie dokie. So the first rectangle, this one at the top here, is going to be given by length times width. So that's going to be x plus 1 multiplied by 4. So let's write that as 4 times x plus 1 in brackets to make sure that everything in that expression gets multiplied by the 4. And then we need to add on the area of this rectangle, which is going to be 2x plus 6 multiplied by x plus 7. So again, let's put those in brackets because we need every term to be multiplied. Okay, so this is going to be equal to our area. So now we need to expand and simplify this expression. So the first bracket, we need to multiply 4 by everything inside that bracket. So 4 times x gives us 4x. 4 times plus 1 gives us plus 4. Okay, now we've got to multiply out a double bracket. So we can use the FOIL technique. So let's just change the pen colour. So that means that we multiply the first terms in the brackets, the outside terms, the inside terms, and then the last terms in each bracket. So with the first terms, we have got 2x times x. That's going to give us 2x squared. Then the outside terms, that's going to be the 2x multiplied by the plus 7. That's going to give us plus 14x. Next up, we've got the inside term. So that's a plus 6 times an x. That's going to give us a plus 6x. And finally, the last terms is the plus 6 and the plus 7. That's going to give us a plus 42. Okay, now we need to collect up like terms. So let's start with the x squareds. There's only one x squared term there. That's the 2x squared. So we'll start with that. That's looking good because that's how our expression is supposed to start. So we're on the right track. 2x squared. Okay, let's collect up our x terms. So we have a 4x, a 14x, and a 6x, all positive. So let's add all those. So 14 plus 6 gives 20, plus that extra 4, we've got 24x. So plus 24x. And finally, let's collect up our normal numbers. We've got plus 4, plus 42. That makes plus 46. Is that what they were hoping it to be? 2x squared plus 24x plus 46. Question 15. Show that 4x plus 3 over 2x plus 3/5 can be written in the form ax plus b over cx, where a, b and c are integers. Alright, so don't freak out at the wording of this question. All integers are just our counting numbers, 1, 2, 3 and so on. So all it wants us to show is that we can write it like this, where a, b and c are some numbers. So it might look like 3x plus 1 over 4. But we can't just pluck the numbers out of anywhere. That's just roughly what it's going to look like. We have to find out what those numbers actually are. And the way we're going to do that is we're going to add these fractions. So we've got 4x plus 3 over 2x plus 3 over 5. Now, when we're adding fractions, we need a common denominator. So we need the denominators of the fractions to be the same in order for us to be able to add them. And an easy way of finding a common denominator is just to multiply the denominators. So if we multiply 2x and 5, we're going to get 10x. So 10x is going to be our common denominator. But if we multiply the denominator of a fraction by something, we have to multiply the numerator of the fraction by that same number to keep the fractions equivalent. So in the case of the first fraction, what did we do to get to 10x? Well, we multiplied 2x by 5. So that means we need to multiply the numerator by 5 as well. So we're going to have 5 times 4x plus 3. Again with the brackets to make sure that everything in that expression gets multiplied. Now, same on the other side. What did we multiply the 5 by to get 10x? Well, we multiplied by 2x. So we need to multiply the numerator by 2x as well. 3 times 2x, so plus 3 times 2x. I'll just put that in brackets and we can work through it bit by bit. Okay, so now we need to simplify this expression. So in the first case, let's multiply 5 by everything inside that first bracket. So 5 times 4x is 20x, and 5 times plus 3 is plus 15. Then we've got 3 times 2x, which is 6x. So we have plus 6x, and that's all just over 10x. Okay, now we need to collect up the like terms. So we've got 20x plus 6x. That's going to give us 26x plus 15 over 10x. And there we have it. That's in the form of ax plus b plus c, with a being 26, b being 15, and c being 10. Okay, question 16. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. Okay, let's start this with a picture. So let's draw out his counters. So he's got 3 red counters and 5 yellow counters in his bag, which is a very long, thin bag, apparently. Okay, so if he's taking out 3 red counters and we need that he takes out exactly 1 red counter, how many ways can he do this? Well, he could either get the red first, and then he could get 2 yellows, or he could get a yellow first, then a red, and the third pick will be a yellow, or he picks 2 yellows and finally a red. So those are the 3 cases where he could take out 3 counters and get exactly 1 red. So we need to work out the probability of all of these events happening. So let's start with the top one. Okay, so while all the counters are still in the bag, what is the probability that he picks a red one? Well, there are 3 red counters and there are 8 overall, so the probability of getting a red on his first pick is just 3 over 8. So now 1 red counter is gone. What is the probability on his second pick that he gets a yellow counter? Well, there are 5 yellow counters left out of 7 counters overall, so we multiply by the probability of 5 over 7 of him picking a yellow counter. But now a yellow counter has gone from the bag, so on his third pick, what is the probability of another yellow one? Well, this time there are only 4 yellow counters out of 6 counters overall. So this is the probability of him picking red first and then 2 yellows. Let's put his counters back in and have a look at the second case. Okay, so this time, what's the probability that in his first pick he gets a yellow counter? Well, at this stage, there are 5 yellow counters out of 8 counters altogether. But then he picks a yellow. So on his second pick, what's the probability that it's going to be red? Well, now there are 3 red counters out of 7 altogether. So he's got a red counter. And for his final pick, what's the probability of yellow again? Well, now there are 4 yellow counters out of 6 altogether. Okie dokie. Let's put the counters back in one last time for the last case. Okay, so when all the counters are back in the bag, we've reset. What's the probability that he picks out a yellow one first? Well, we've got 5 yellow out of 8 altogether. But then he's picked a yellow. So what's the probability that he gets yellow again? Well, this time there's only 4 yellows left out of a total 7 counters. And he's taken one of those. So what's the probability that his third pick, he gets a red? Well, now there are 3 red counters out of a total of 6. Okie dokie. So we've got our 3 probabilities, but what can we notice here? They are all the same. They are all some version of 3 times 4 times 5 over 6 times 7 times 8, just in different orders. So let's multiply this. We can do a bit of cancelling. We can divide top and bottom by 3, first of all. That cancels that 3 to a 1, and this 6 to a 2. And then we can cancel top and bottom by 4. We divide by 4. So that's going to cancel this 4 to a 1 and this 8 to a 2. Now that looks a bit easier to multiply by. Just budge this over a bit. We're going to get 1 times 1 times 5 in the numerator, which gives us 5. And then 2 times 7, which is 14, times that second 2 is 28. So each of these probabilities is 5 over 28. And now what we have to do, because any one of them could happen, it could be the first case or the second case or the third case. So we have to add up all of those probabilities. That's 5 over 28 plus 5 over 28 plus 5 over 28. We've already got a common denominator, so we can go ahead and add the numerators. 5 plus 5 plus 5 gives 15 over 28. All right, let's take another quick break there. I really hope you enjoyed this video. Let us know if you did by hitting the like button. If you have any questions at all, drop those in the comments and we'll do our best to answer them. Don't forget to subscribe to Sums of Anarchy for more maths tips and tricks, and we'll see you again for the final part in this Let's Solve series. See you later.